Weather forecasting is an essential part of modern life. It affects everything from the clothes we wear to the plans we make for outdoor activities and how we prepare for severe storms. But have you ever wondered how meteorologists predict the weather? In this video, we'll dive deep into the science behind weather forecasting, exploring the key methods, tools, and technologies that meteorologists use to provide us with accurate weather predictions. From collecting data to analyzing weather patterns and using supercomputers to model the atmosphere, weather forecasting is a highly sophisticated process. At the most basic level, weather forecasting starts with understanding the Earth's atmosphere. The atmosphere is a dynamic system, constantly changing due to temperature, air pressure, humidity, and wind patterns. These changes are what cause the variety of weather conditions we experience daily, such as rain, snow, clear skies, or strong winds. Meteorologists study these patterns closely to predict what will happen in the future. The first step in weather forecasting is data collection. Meteorologists gather data from multiple sources, such as ground-based weather stations, weather balloons, satellites, and radar systems. Weather stations are scattered across the globe, collecting data on temperature, humidity, wind speed, barometric pressure, and other essential weather parameters. These stations are located in a variety of settings, from remote locations to urban areas, ensuring that meteorologists receive a broad spectrum of data from different regions. Weather balloons are another crucial source of data. These balloons are equipped with instruments called radiosondes that measure temperature, pressure, and humidity as they rise through the atmosphere. They provide invaluable data, especially at higher altitudes, where weather systems can be different from those at ground level. Weather balloons are typically launched twice a day, giving meteorologists real-time information on the atmosphere's state and allowing them to monitor how weather systems are evolving. Satellites are essential tools for modern weather forecasting. Positioned high above Earth, satellites provide a bird's-eye view of cloud cover, temperature patterns, and atmospheric moisture. They capture images and data across vast regions, allowing meteorologists to track large-scale weather systems like hurricanes, typhoons, and other storms as they develop and move across continents and oceans. These satellites also help track the position of weather fronts and monitor the planet's overall climate system. Another critical tool in forecasting weather is radar. Weather radar systems send out electromagnetic waves that bounce off precipitation in the atmosphere, such as rain, snow, or hail. By measuring the return of these waves, meteorologists can determine the intensity, location, and movement of precipitation. Radar also allows meteorologists to monitor the development of thunderstorms, tornadoes, and severe weather events in real time, providing early warnings to areas that may be at risk. Once the data is collected, meteorologists use advanced computer models to predict future weather. These models are highly sophisticated mathematical simulations that replicate the behavior of the atmosphere based on the data provided by weather stations, satellites, radar, and weather balloons. These models take into account factors such as wind patterns, temperature differences, and pressure systems. Meteorologists use these models to predict how weather systems will evolve over time, helping them forecast conditions hours, days, and even weeks in advance. The complexity of weather models is astounding. They run calculations on the interactions of thousands of variables to predict how the atmosphere will behave in the coming days. These models split the atmosphere into grid boxes that represent areas of the Earth's surface, and each grid box contains data about the temperature, humidity, pressure, and wind speed in that region. The model then simulates how these variables will change over time and how they will interact with each other, creating weather patterns. The more data that is fed into a model, the more accurate the predictions tend to be. Meteorologists run these models on supercomputers, which are capable of processing vast amounts of data very quickly. This allows for highly detailed forecasts, such as predicting a storm's path, its intensity, and when it will reach a specific location. Supercomputers also enable meteorologists to create different forecast scenarios by adjusting certain parameters, which helps to account for uncertainty and improve the overall reliability of predictions. In addition to computer models, meteorologists must also be familiar with basic weather patterns and systems. The atmosphere is made up of different pressure systems, and understanding how these systems interact is key to forecasting. High-pressure systems are generally associated with clear, calm weather, while low-pressure systems often bring storms and unsettled weather. The movement of these systems is closely tracked to predict how weather will change over time. For instance, when a cold front meets a warm front, the warm air is forced upwards, creating an area of low pressure. This can result in clouds, rain, or even thunderstorms. Meteorologists track the movement of these fronts to predict when and where storms will form. Similarly, weather patterns like cyclones, hurricanes, and monsoons are all studied to make predictions about their impact on different regions. By understanding the historical patterns of these systems, meteorologists can make predictions about where they are likely to occur. Despite advances in technology, weather forecasting is not an exact science. The atmosphere is incredibly complex, and small changes in one part of the system can have a ripple effect that leads to different outcomes. For this reason, short-term forecasts, from a few hours to a day, tend to be more accurate than long-term predictions. The further in advance you try to predict the weather, the more uncertainty there is. However, meteorologists are constantly improving their models, and forecasts for up to 7 days are generally reliable for most locations. Severe weather, such as tornadoes, hurricanes, and blizzards, presents additional challenges for meteorologists. These types of weather events often involve rapidly changing conditions that are difficult to predict accurately. However, modern technology has allowed meteorologists to improve their ability to forecast extreme weather events. With radar and satellite technology, meteorologists can track the formation of hurricanes or tornadoes and issue warnings much earlier than in the past, saving lives and reducing damage. Space weather is another growing area of research in meteorology. Solar flares and coronal mass ejections can impact Earth's magnetosphere, causing disruptions to satellite communications, GPS systems, and power grids. Scientists are studying space weather to better understand how these solar events affect Earth's atmosphere and technology, and to develop forecasting methods that can predict these phenomena. Weather forecasting continues to improve thanks to advancements in technology, from satellites to supercomputers and better mathematical models. By understanding atmospheric processes and utilizing cutting-edge tools, meteorologists are better equipped to predict the weather and keep us informed about what's coming next. Despite the challenges, weather forecasting remains a crucial part of our daily lives and is a testament to how far science has come in understanding our planet's dynamic atmosphere.